Alright, so just a quick review on all things growth and decay. So when we were talking about growth and decay, if you remember when we talked about growth, we said that y equals p times 1 plus r raised to t. And when we talked about decay, we said that y equals p times 1 minus r raised to t. So just a few key things to point out and to kind of help you remember here is our P is our initial amount. Okay, so whatever that may be, that is what we're going to start off initially. And then our base, I hope we can address the fact that 1 plus r is my base. For either growth or decay, it has to have a rate that is included with it. So my rate, which is a big deal, my rate has to be divided by 100 in order to convert it into a decimal. Now, I did notice on a few of the problems for growth and decay that y'all did that several of you either forgot to divide or you divided incorrectly. So I'm really going to try to focus on that with a couple of examples. And if you remember, T is going to represent time. Alright, so if I give you an example and I say that, let's say your initial amount is $2,000, and I say that your rate is 4.5%, and I tell you that it's growing, then that means that we are going to have to do 1 plus r. So I'm just going to write a simple model. I'm not even going to actually calculate the value at this moment. But if I'm going to divide my rate, so I have 4.5 divided by 100. And 4.5 divided by 100 is going to be 0.045. A lot of you actually in the examples, a lot of you that got it wrong put just 0.45. And 0.45 is the same thing as 45%. I'm looking for 4.5%, which is going to be 0.045. So just be very careful when you're converting your percentages, okay? Because that completely made the rest of your problem incorrect. So we're going to plug in what we know. So we're going to plug in 2,000. Because remember, our formula for growth is y equals p times 1 plus r raised to t. So this is going to be 1 plus, and right here is where I'm going to put that rate. So my rate is 0.045. And I'm going to actually add my base and get one number. So when I add that base, I get y equals, so I have 2,000, and my base is now going to be 1.045 raised to t. That is the model for that equation. Okay? So just keep that in mind. Now, let's say that I completely change what I just said, and I ask you to find the decay part. Alright, so I'm going to give you the exact same information. So this is still going to be 2,000. I'm still going to have a rate of 4.5%. But now I want to decay. So remember, decay is y equals p times 1 minus r raised to t. So this is going to be y equals 2,000. My 4.5% divided by 100 is going to equal 0.045. Same thing, except for this time I'm going to be subtracting. Okay, so we are going to calculate this base. And again, so we are aware and we are making sure that we are looking closely is that this should be subtraction, 1 minus. Alright, so when I subtract this, it should be less than 1 because we are subtracting it 1 minus. So this is going to turn into this is going to be 0.955. If you don't want to put the 0, that's fine, because it's in front of the decimal, so it's not going to change anything. If you just put 0.955 or 0.955, that's fine. Alright, so that represents decay. Now, I want to actually take this one step further, and I want to talk about how to find the rate. Now, we did this in last class, but I just want to review it because the base, again, is not the same thing as the rate. So if we have growth, remember, if we want to find the rate, this is going to be for a growth rate, we're going to say that we're going to take the base, because the base is going to be greater than 1, and subtract 1. But once we do that, we have to times our decimal by 100. Okay, that's to put it back into a percentage. Alright, if we want to do decay, and we want to find our rate, then we're going to do 1 minus the base, because if it's decay, the base is less than 1, and then we're also going to multiply it by 100. So just keep that in mind. So if I give you the example, y equals 200, and my base is 0.85 raised to t. Okay, so my initial value is 200, and my base in this problem is 0.85. I want you to find the rate. That is what I'm asking you to find. Again, the base, 0.85, is not the rate. So this is decay. And since it's decay, to find my rate, I'm going to say 1 minus the base. So if I do 1 minus 0.85, then that's going to give me 0.15. But remember, I need to multiply that by 100 in order to get my percentage. So my rate of decrease, so it's decreasing because it's decay, is decreasing by 15%. Okay? Alright, so for this example, again, this is decay. I know it's decay because my base is less than 1. So to find my rate, I'm going to say 1 minus the base. Alright, so 1 minus 0.73 is going to give me 0.27, but I'm going to multiply that by 100. And that's going to give me 27%. Alright, so now let's look at a growth example. So let's say that I have a growth of 1.03. So again, I know that my initial value in this problem is 20. And I know that my base is 1.03. And with that base, I know that it's growth because it's greater than 1. So to find my rate, okay, is what I'm looking for. I'm going to say my base minus 1, because my base is larger than 1, so I don't want my answer to come out to be negative. So my base is 1.03 minus 1. And that gives me 0.03. But just like all the rest of them, I'm going to multiply it by 100. And that's going to give me my percentage, which is 3%. Alright, so this problem is going to represent growth. So since it represents growth, that means I'm going to take my base and subtract 1 in order to find my rate. So my base is 1.37, subtract 1. It's going to give me 0.37 multiplied by 100. And this is going to be a growth of 37%.